Hi guys, it's me, Mr. Roundy, and I'm here to start today's lesson. And we're going to start today's lesson by learning a vocabulary term and kind of how to tell this vocabulary apart from other things. So, our vocabulary term, as you've already read, is linear expression. Now, linear expression is an algebraic expression, which means it has variables, that has no exponents, and none of the variables are multiplied together. So I've got a little chart down here to help us understand what that means. So I've got a list right here of linear expressions. We can see that this one says 5 times x or 5x. This is a linear expression. It doesn't have any exponents, and the variable x isn't being multiplied with any other variables. Now on the other side here, we have a nonlinear expression. And you'll notice that this one is 5 times m times n. And what makes this one nonlinear is the fact that we've got the variable m and the variable n that are being multiplied together. Another example of a linear expression down here, 3x or 3 times x plus 2. Once again, no exponents, and the variable x isn't being multiplied with any other variables. Here we've got another example of a nonlinear expression, 3x squared. If you see an exponent, you know that it's not a nonlinear expression. Same for this next one. X minus 7 would be linear. X to the fourth minus 7 would not be because we've got an exponent again. So linear, there's no exponents, and the variable isn't multiplied with any other variables. Okay, so let's go ahead and look at something else. Okay, so we're going to be adding linear expressions today. Let me adjust and see if I can get that's a little clearer. And let's go ahead and look at a problem that we did yesterday. Yesterday, we were adding, subtracting, doing whatever we needed to combine like terms so that we could simplify expressions. So if we're looking at this particular expression, we have 4x and 6x are like terms, which means that we can combine them together. So I have a 4x, and I notice the sign in front of my 6x is a plus sign. So that means I would do 4x plus 6x, and that's going to get me a total of 10x. My minus 5 is still here, so I just tack that onto the end, and here is my new simplified expression. Now we're going to be doing something similar today, but we're going to be seeing some parentheses with these. So it's going to make them a little bit longer. So we're going to be taking multiple linear expressions and adding them together. Here's our first example of adding linear expressions. As you can see here, I've got 2x plus 3 in parentheses, and I've got x plus 4 also in parentheses. Now, if you take a good look at this one, you'll see that every sign in here is a plus sign, which means that I could actually use several different math properties on this problem. First off, I don't even have to have these parentheses because everything is being added. That's associative property. Associative property says I can group these however I want and I'll still get the same answer. I could also move different pieces around because commutative property says that I can move them around because everything is being added. However, I really am not going to worry about that right now. Right now, all I'm going to be really worrying about or dealing with is my like terms. I've got 2x and x, and I've also got 3 and 4. And so I've got 2x, and now this is a plus sign, and I'm adding x. So 2x plus x is going to get me 3x. And I've got 3, and I've got a plus 4. That's going to get me a 7. So that would be a plus 7. And I've now combined these two linear expressions, linear expression, linear expression, and I've added them together, and I've gotten 3x plus 7. Here's a second example. Now with this example, it's a little bit different because rather than having plus signs inside of my parentheses, I've got subtract signs. So since I've got two linear expressions here, what I like to do with these is I actually like to stack them, kind of like we used to do with math when we were little kids, when we'd have problems like 7 minus 5. Well, we would then write it like this. to solve it. And we would then get 2. So I'm going to do something similar with these two linear expressions. I've got 2x plus 1, or sorry, minus 1, and that's being added to x minus 5. So I'm going to take these piece by piece. And the first thing I'm going to do is do my x's. I've got 2x plus x gets me 3x. Now I've got to think about this second part right here, and I'm going to treat these minus signs like negative signs. Basically, anytime I've got a minus sign in an expression, I'm going to treat it like it's a negative. So this problem is going to basically be -1 plus -5. If I do -1 plus -5, that's going to get me -6. And I write it like -6, but now it's a subtract sign. So my overall final answer is going to be 3x minus 6. Here's another example problem of adding linear expressions. I've got 2x minus 3 plus -x plus 4. Now, one thing that maybe confused you on the last problem is I said treat all minus signs like negatives, and here's why I can do that. The rule when we're subtracting with numbers, or when you've got a problem like -2 minus 3, remember the rule is add the opposite. So I can follow that anytime that there is a subtraction sign. I can just treat it like it's a negative, because if I did add the opposite, my number is negative. So that's why I can treat minus signs like they're negative signs. So I've got 2x minus 3, or 2x plus -3, plus -x plus 4. So once again, I'm going to stack these to help add them together. I'll put some parentheses to show that that's a negative. Now I've got minus x plus 4, and all of this is being added. So I'm going to put some parentheses to show that that's a -x. So basically, I've got 2x plus -x. Well, if I've got the signs are not the same when they're being added, then I subtract. So that would be 2x minus an x. That would just get me x, 1x, or just x. I don't have to put the 1 in front. So I've got x, good. Now I've got -3 plus 4. So -3 plus +4, that gets me 1. And I would have a plus sign between them because it's a positive 1. And here is my final expression after I've simplified by adding those two linear expressions together. In this example, you're going to notice that there's something a little bit different about it. I've got this 2 on the outside. Now, we go back to lesson 4 and what we learned about distributive property, we know how to deal with this 2. When I've got something in parentheses being multiplied by something outside it, then I can use distributive property to distribute that 2 to both things inside the parentheses. So I'm going to simplify this a little bit by doing distributive property. 2 times x is going to get me 2x, and 2 times 3 is going to get me 6. It's a plus sign between them, so I keep the plus sign. Now I've got a linear expression, 2x plus 6. I can just put that in parentheses. Now my problem is 2x plus 6 plus 3x plus 1. And I can stack them again if I like. 3x plus 1, 2x plus 6, and those are being added together. So if I do this part right here, I've got 3x plus 2x, that just gets me 5x. And I've got 1 plus 6, that gets me 7, and it's positive, so it's a plus sign between them. And we get the expression 5x plus 7 for our final expression, or our simplified expression. Here's a second example of the problem that requires us to do some distributive property. So once again, I've got 5 times x minus 4 plus 2x minus 7. So I'm going to start by simplifying things a little bit by getting rid of this 5 that's outside the parentheses using distributive property. This means 5 times x is going to get me 5x. And 5 times 4 is going to get me 20. Now, if I treat this, since it's got a minus sign, like a -4, that means my answer would be -20 or minus 20. Okay, now I've still got 2x minus 7 over here, and I can just put these two in parentheses now so that I can have my two separate linear expressions be added together. I'd write that by stacking them, 5x minus 20 and 2x minus 7, and I'm going to be adding those. And so I've got 5x plus 2x gets me 7x, and I've got negative 20. Remember, I treat minus signs like negative signs. Negative 20 plus negative 7 gets me negative 27. And my answer is 7x minus 27. Here's an example of a problem where we might use this adding of linear expressions. So here I've got a triangle, and for the sides of my triangle, I have 3x minus 3, 5x, and 2x plus 9. It didn't give me the exact value in centimeters, so it's just given me these linear expressions to represent the lengths of each side of this particular triangle. Now, if I wanted to find the perimeter of this triangle, then I could make an expression to represent it. And the way I would do that is by adding my three linear expressions together, because that's how we find perimeters, add up the sides. So I would do 3x minus 3 plus 5x plus 2x plus 9. Now I can simplify this expression because it's super long and complicated. So let's try and simplify it. We'll start by adding the first set of terms, or the first set of linear expressions. So I've got 3x minus 3 plus 5x. And since there's nothing here, I won't put it. So 3x plus 5x gets me 8x, and I still have the minus 3, so I keep the minus 3. Now I'm going to add this 8x, and I'm going to write it up here so I have some room. 3x minus 3, and I'm going to add that to the 2x plus 9. I've got 8x plus 2x gets me 10x, and I've got, remember this minus sign, I'll treat it like a negative, I've got negative 3 plus positive 9. So negative 3 plus positive 9, that's going to get me positive 6. And so my final answer is going to be 10x plus 6. And this is a simplified expression that can represent the perimeter of my triangle. Now let's say I know the value of x. Let's say that they come in, they tell me that x equals 5. Well, that would be pretty easy to solve now. All I'm going to do is plug 5 in for x in my expression. 10 times 5 is 50, plus 6 gets me a perimeter of 56. Okay, that's the end of our lesson. Hope you enjoyed it, and have a great day.